Okay, hey guys. Today we are factoring out greatest common factors, GCF, greatest common factors. Yeah, that's great. Okay, greatest common factors, GCF. So for example, let's just talk about what a factor is. If you had the number 10, you can break that up into smaller pieces that multiply together to get 10. So, for example, 2 times 5 will give you 10. There are other factors of 10, so you could have 10 times 1. And then you can also do things with the signs. So you could have like negative 2 times negative 5, or you could have negative 10 times negative 1. Okay, so these are factors of 10 that when you multiply these two factors together, they will give you 10. We can make a factor tree. So this is kind of a tree, but it's kind of a short tree. And this tree looks bananas. So let's pick a number, for example, like 48. Okay, so 48 can be factored, and we're going to use a factored tree. So 2 times... Sorry, I had to answer the phone. Okay, 2 times 24, and then we can keep going. We've got 2 and 12, 2 and 6, and 2 and 3. Okay, these are factors of 48. Now, if we're talking about the greatest common factor, you need two numbers. So for an example, we have 48, and let's just pick 52. Okay, so we're trying to find the greatest common factors. So we're going to make another factor tree. So 52 divided by 2 is 26, divided by 2 is 13, and 13 is prime. So we're going to stop. Okay, so if we're trying to find the greatest common factors between two numbers, we're looking for what they have in common, and we're looking at the ends of these trees. So this is a factor tree, and this is a factor tree, and we're looking at the ends. So I know that 2 of these and 2 of these both match. Okay, so let's change that a little bit so that it's a little bit more pretty and concise, which just means squish it together. Okay, 2 times 2 is really 4, and the business that we have left over, 2 times 2 is 4, and 4 times 3 is 12. So 4 times 12 equals 48. And then here the same thing, 2 times 2 is 4, and then 13 is there. So 4 times 13 is 52. So between the two numbers, 48 and 52, the biggest or greatest common factor is 4. So 4 is in both 48 and 52, and it's the largest number that 48 and 52 share. And I did this by looking at factor trees. Now some of these numbers are a little bit more obvious, especially when we're doing some simpler equations like we're going to be doing today. But this is the idea that we're going for. The same thing happens with letters. So if I had an m squared that I'm comparing to an m to the 4th. So I know that there are 2 m's here, and there are 1, 2, 3, 4 m's there. Well, the greatest amount of m's that they each have in common is 2. So the greatest common factor between these two would be m squared, which it's a lot more obvious in the letters, than it is in the numbers. But this is the idea that we're going for. We're trying to figure out the greatest amount that they each share. Now, sometimes you have letters and numbers, and you also have some sort of an expression. So, for example, if I had like 4m to the 3rd and 12m to the 5th. So what we're going to do is we're going to take out the biggest numbers that can go in each of them, the greatest common factors. So 4 can go into it itself, and it can go into 12. So the biggest number to come out of both of these terms is 4. Then I look at my m's. Well, I have a 3 and a 5, so the biggest amount of m's that can come out is a 3. So the greatest common factor between these two numbers is 4m cubed. Now this is what we do with it. We're going to change this expression into a distribution problem. So we're backwards distributing. So we figured out the greatest common factor and we took that out. Then we're going to leave two terms inside of our parentheses to represent the two terms that we have. Well, this is the exact same thing as this, so if I were thinking about multiplying, then 1 is left over. This guy, in order to multiply to get 12, I need to think of what number multiplies by 4 to get 12, or basically what's left over. So if I take 4 out of 12, I have 3 left over, and if I take 3 m's out of my 5, I have 2 m's left over. This is the answer, because I'm asking for the greatest common factor and for it to be factored out. So I took my greatest common factor between these two was 4m cubed. I took that out, and I factored that out by leaving some business left over. That's because if I wanted to, 4m cubed 1 plus 3m squared, if I wanted to distribute here, I would have 4m cubed, because 4m cubed times 1 is 4m cubed, and then I would have 3 times 4, which is 12, add my exponents, m to the 5th, which is the same thing that we started with. Okay, it's kind of tricky. So we're going to keep going. We're going to do a few more examples together, and then you guys can practice on your assignment. Let's say that I had 8 g squared h cubed and 16 g cubed h5 minus 4 g h8. Okay, so I want the greatest common factor in all of these, and it has to appear in all 3 of them. So I look at my numbers. The largest number that can go into each of these numbers is 4. 4 can go into 4 one time, 4 can go into 16 twice, and 4 can go, or 4 times, sorry, and 4 can go into 8 twice. So my 4 is my largest number that I can take out of this expression. Then I look at my g's, okay, and we're looking for the smallest exponent. So we have a 2, a 3, and a 1. So just 1 g then. The same thing with the h's. You're looking for the smallest number of exponent. 3, 5, 8, well that's a 3. So the greatest common factor between these 3 terms is 4gh cubed. So now I'm going to leave the remaining things in their correct terms. So if I take 4 out of 8, I'm left with 2. If I take 1g out of g squared, I'm left with 1g. And if I take 3 h's out, well then I don't have any more h's. Next term, if I take 4 out of 16, I have 4 left over. If I take 1g out of 3g, I have 2 left over. And if I take 3 5s out of 5 5s, then I have 2. Bring down your negative. If I take 4 out of 4, I have 1. We don't need to write 1. G out of g, I have no g's. 8 h's and 3 h's, I have 5 h's left. If you wanted to check to make sure you did it correctly, just distribute it through. Okay, should we do one more? All right, we'll do one more. Okay, let's say we had 5a 4b6 minus 55 a6b4. That's fun. Okay, so I look at my numbers to start. The greatest number that's in both of these numbers is 5. So I'm going to take my 5 out. Oh, then we have to do the a's. Sorry, my bad. Okay, then we look for the smallest amount of a's. We have 4 a's and 6 a's, so we pick the 4. And then the smallest amount of b's, we have 6 a's and 4 b's, so we're going to pick the 4 again. Now we write whatever's remaining inside of our parentheses. Well, I took out the 5, I took out my 4 a's, so I have 2 b's left at the beginning. And then 55, if I take 5 out, I have negative 11. If I take 4 of my 6 a's, I have 2 a's, and then I don't have any b's. So this is my final answer. All right, if you have any questions, please let me know. Bye, guys!